Hello everyone. I am teacher Lee Yongle. Recently, a student asked me a question. Teacher, I spent $400 on a top-tier sleeping bag, rated for -20 degrees Fahrenheit. I went camping in the snow thinking I was invincible, but in the middle of the night, I was shaking so hard. I thought I was going to die. Did I buy a fake product? This is a very classic misunderstanding of physics. In the outdoor industry, there is a massive information asymmetry. Today, we are not going to discuss brands or fabrics. Instead, we are going to use thermodynamics and heat transfer physics to derive why your expensive gear turns into a coffin, and how the second law of thermodynamics is the ultimate arbiter of your survival. The core definition, insulation versus heat source. First, we must correct a fundamental cognitive error. Many people think sleeping bag, ferdy heater. From a physics perspective, this is completely wrong. A sleeping bag is not a heat source. It is a thermal insulator. In an electrical circuit analogy, your body is the battery voltage source, and the sleeping bag is the resistor. Bag's only job is to increase the resistance to heat flow. According to the second law of thermodynamics, heat explicitly flows from a high-temperature object to a low-temperature object. Until thermal equilibrium is reached, your body is at 98.6 degrees Fahrenheit, and the environment is at -20 degrees Fahrenheit. The universe hates this temperature difference and will do everything in its power to equalize it, which means cooling you down to -20 degrees Fahrenheit, also known as death. The -20 degrees Fahrenheit rating on the bag does not mean comfort. In the standardized testing and ISO standards, this rating is often the lower limit, point at which a standard male can survive without dying of hypothermia. It does not guarantee sleep. It only guarantees you maintain a pulse, while shivering violently to generate metabolic heat. The equation of heat loss, 4 variables. To survive, we must solve a differential equation. We need to minimize the rate of heat loss. Heat leaves your body through 4 specific pathways. If you block 3 but leave 1 open, the result is still freezing. Let's break them down logically. 1. Conduction, the infinite heat sink. Conduction is heat transfer through direct contact. The formula for conductive heat transfer is Q, where D is the thickness of the insulation. Here lies the trap. When you lie inside your fluffy, down, sleeping bag, your body weight compresses the insulation underneath you. The loft thickness D goes from 3 inches to 0.25 inches. Once the air is squeezed out, you are essentially lying on a thin sheet of nylon directly against the frozen ground. Geologically speaking, the Earth is an infinite thermal mass. You cannot warm up the Earth. The Earth will simply drain your heat indefinitely. This is why R value matters more than the bag itself. You need a sleeping pad. Without a high R-value pad, your $400 bag is mathematically useless. 2. Convection, fluid dynamics. Convection is heat transfer via the movement of fluids, air. Inside the bag, your body heats a thin boundary layer of air. This is your life support. However, hot air is less dense, so it rises. Cold air is denser, so it sinks. This creates a convection current. If there is empty space in your bag, the air circulates, stripping heat from your body. This is why mummy bags are efficient. They minimize the volume of air you need to heat. Furthermore, the opening around your face acts as a chimney. Hot air rushes out and cold air rushes in. If you don't cinch the hood tight, you are physically pumping heat into the forest. 3. Radiation, the Stefan Boltzmann law. Every object above absolute zero emits thermal radiation. The power radiated is proportional to the 4th power of temperature. You are a biological light bulb emitting infrared radiation. Your sleeping bag is good at stopping conduction and convection, but it is often transparent to radiation. If you sleep under a clear night sky, you are radiating heat directly into deep space, which is effectively near absolute zero. This is why cloudy nights are warmer. Clouds reflect AR back. To solve this, we use reflective barriers, like space blankets or tents, to reflect those photons. Back to the source, 4. Evaporation, the phase change penalty. This is the most dangerous variable. When water turns from liquid sweat to gas vapor, it undergoes a phase change. The latent heat of vaporization for water is approximately 540 calories per g-ram. This energy must come from somewhere. It comes directly from your skin. If you hike to your campsite and sweat, or if you wear cotton, which holds water, you are coating yourself in a coolant. Water conducts heat 25 times faster than air. Wet insulation implies thermal conductivity skyrockets. and insulation efficiency drops to near zero. If you enter a sleeping bag wet, you turn the bag into a humidity chamber. The moisture condenses in the insulation, collapsing the loft and accelerating heat loss. This is a positive feedback loop leading to hypothermia. Third, the biological reactor, input versus output. Finally, let's look at the battery of our system, your metabolism. The sleeping bag is a container. A container cannot keep a cold object warm. Your body generates heat through chemical reactions, burning glycogen and fat. If you go to sleep on an empty stomach, your reactor runs out of fuel. The shivering you experience is your body's emergency mechanical heat generation protocol, but it burns fuel rapidly. Once glycogen is depleted, your core temperature plummets. Therefore, logically, the most important survival gear is not the bag but high-calorie food, eaten right before sleep. You must exploit the thermic effect of food to keep the furnace running. Conclusion. Let's summarize the logic. Survival is not about buying gear. It is about solving a thermodynamic equation. 1. Stop conduction. Use a high R-value pad to decouple from the infinite heat sink of the ground. 2. Stop convection. Eliminate dead airspace and close the chimney. 3. Stop radiation. Use shelter or reflective layers to bounce air energy back. 4. Stop evaporation. Manage moisture, no cotton, and prevent sweating. 5. Fuel the reactor. Eat fat and carbs to maintain metabolic output. The laws of physics do not care about your credit card limit or brand loyalty. The cold is simply entropy doing its job. Only by understanding these 4 mechanisms can you use rationality to defeat the second law of thermodynamics and survive the night. I am teacher Lee Yongle. See you next time.